Let us discuss Levi Civita symbol. And this is also called permutation symbol. First, let us mention where this symbol finds its use. So Levisivita symbol or permutation symbol is used in various branches of physics and mathematics. We now come to the definition of Levisivita symbol or permutation symbol. It is denoted by epsilon, I, J, K, and I, J and K are dummy indices or run indices, and they take values say 1, 2, 3. Epsilon ijk, that is the Levisivita symbol, will be +1 if these indices permute cyclically, that is for cyclic permutation or occurrence, and it will be -1 for anticyclic permutation or occurrence of these indices, and it will be 0 otherwise. And this will involve repeating indices. Let us explain what we mean by these statements. So, explanation. Let us consider the indices I, J, K, assuming values say 1. Now after 1 comes 2, and after 2 comes 3, and after 3 we have to revert back to 1, and we note that after 1 occurs 2 and before 1 occurs 3, so we can place a 3 here. So it is 1, 2, 3, 1, 2, 3, 1, 2, 3, and so on and so forth. This is how the flow goes. And if this occurs, we say cyclic permutation or cyclic occurrence of the indices. For instance, epsilon 1, 2, 3. After 1 comes 2 and then comes 3, so its value will be +1. If we start with 2, after 2 is 3 and then is 1. So the value of it will also be +1. Let us start with 3. So after 3 it is 1. After 1 it is 2. Now all these will have the value +1. So Levisivita symbol is +1 for cyclic occurrence of the indices. Let us now explain the anticyclic occurrence of indices. So let us start with 1. For cyclic occurrence after 1 we should have 2, but for anticyclic occurrence this rule should be broken and we have to take the integer that occurs before 1, and that is 3. So 2 should not follow 1 but 3 should, and therefore after 1 we have 3 and then it is 2. So this is anticyclic occurrence of indices for which the value of Levisivita symbol is -1. Suppose we start with 2, after 2 comes 3, but we will not take it, we will take 1. Following it, so it is 2, 1, 3, the value of which is -1. Let us start with 3, after 3 1 should come, but let us break the order, and so instead of 1 we should put 2. that precedes 3. So it is 3, 2, 1. So all these are instances of anticyclic occurrence of the indices 1, 2, 3 for which Levisivita symbol is -1. So there are 3 components of Levisivita symbol corresponding to cyclic occurrence of indices and 3 components of Levisivita symbol corresponding to anticyclic occurrence of indices. Let us explain this repeating case. In other words, let us consider the remaining components of Levisivita symbol, the remaining possibilities of the arrangement of the indices that can happen or occur. Let us consider possibilities when all the indices are same. This corresponds to epsilon 1, 1, 1, epsilon 2, 2, 2, and epsilon 3, 3, 3. And since the indices repeats, the value of Levisivita symbol is 0. Now let us consider situations in which 1, the index 1, occurs twice. Here 1 occurs thrice, but we will consider situations in which 1 occurs twice, and these are now just replace 2 by 3. There are 6 cases. Here we have 3 cases. Here we have 6 cases. Situations where 2 occurs twice. Epsilon 2 to 1, epsilon 1 to 2, and so on. Now we have to replace 1 by 3. So again 6 components are there. And finally, Levisivita symbol in which 3 occurs twice will have 6 more components, namely 331, 133, 313, and now replace 1 by 2. So altogether there are 21 components, and this means Levisivita symbol has 27 components. Having explained the 27 components of Levisivita symbol and written down their values, let us take some isolated examples. What will be the value of, say, 213? What will be the value of, say, 111? 321. So in this example, after 2 comes 3, but here 1 is there. So obviously the cycle is broken, it is anticyclic, so it will be -1. In this case, we have 3 repeating indices, and therefore it is 0. And here, after 3, 1 should come, but here we have 2, which means it is not cyclic, and therefore it is -1. In this example, after 3, 1 is there, so it is cyclic, and therefore it is +1. Let us now mention why we will use Levisivita symbol. Levisivita symbol is used to make formulae or law or certain expressions become compact they become short and they become elegant. And also, with the help of Levisivita symbol, derivations become very short. So with it, the derivations will not run into pages, but will run into few lines. We shall discuss various applications in the video on application of Levisivita symbol. For instance, vector product can be expressed elegantly with Levisivita symbol. Determinant can also be expressed in short using Levisivita symbol, and so on. Also, scalar triple product of unit vectors can be expressed elegantly and in a short or compact form using Levisivita symbol. Let us write down the properties of Levisivita symbol. Let us interchange I and J, and we get JIK. Since there is one exchange, that is odd number of exchanges, it will be minus. So this is how they are related, but let us make another exchange between I and K. And this gives us, so minus was there, and since another exchange means another minus will come, we will have JKI. So it is JKI, and minus minus is positive, and these two are related by two exchanges or even number of exchanges. So one exchange lead to minus, but two exchanges lead to plus. And the rule is, for odd permutations or odd exchanges, we'll have minus, and for even exchanges or even permutation, we'll have plus. So example, let us start with 1, 2, 3. Let us make one exchange of 1 and 2, so it becomes 2, 1, 3, and it will be preceded by a negative sign. If we make a further exchange of 1 and 3, then we have 2, 3, 1, and another negative will come, and minus minus is plus, so we have plus 2, 3, 1. So it follows again that one exchange will extract a negative sign out, but two exchanges will keep it plus. And the reason is that after one exchange, the cyclic permutation is destroyed and we have anticyclic permutation, because here after 1 comes 2, but here after 2, 3 should have come, but there is 1, which means the permutation is anticyclic. But after two exchanges, the cyclic permutation is preserved, because after 2 we have 3 and after 3 we have 1. The relation obtained by interchange of I and J, or we can obtain a relation by interchanging J and K as, means that Levisivita symbol is antisymmetric. We shall express Levisivita symbol in terms of Kroneckar deltas as follows. this product can be expressed through a determinant, the rows and columns of which are populated by Kroneckar deltas. And now we have to fill it up in this way: IP, IQ, IR. So that fills up the first row. For the second row, we'll start with the second index, JP, JQ, and JR. And similarly, the last one, we start with K, so it is KP, KQ, and KR. So this is the general expression, and let us mention that Levisivita symbol involving 3 indices is a tensor of rank 3, and here the product represents a tensor of rank 6, as evident from the occurrence of 6 different indices. We next mention another very useful property which we shall also prove, and that is so let us consider this product, but now these 2 indices are same. So it is I here and it is I also here. Now expansion of this determinant gives Kroneckar delta JL into Kroneckar delta KM. Then minus, then again we have 2 Kroneckar deltas that involve JM and KL. This is an extremely useful relation. We'll prove it starting from this determinant. And let us mention that now we have a tensor which is of rank 4, because sum is over the repeated index I, and so the final result will no longer involve I, and we have a tensor of rank 4 as evident from the occurrence of 4 indices. Let us start with and write it in the form of a determinant. Let us begin by writing II, then IL, IM, and then JI, JL, and JM, and finally KI, KL, and KM. We'll get this result from here after 2 steps. Let us expand it and write as follows: delta II, delta JL, delta KM, minus delta JM, delta KL, then delta IL, and now it will be delta JM, delta KI, minus delta JI, delta KM. And then delta IM, and we have the cross product of delta JI, delta KL, minus delta JL, delta KI. In the video on Kroneckar delta, we showed that Kroneckar delta II is 3. Using it, we get 3 into the product of these two Kroneckar delta. And similarly from this term, and then from the second set of terms we have and finally from the third set of terms we have reached the penultimate step, and let us write it down. 3 JLKM minus 3 Kroneckar delta JM KL. And let us look at the third term. So it is plus delta JM, and we find that I repeats which can be contracted. So these two Kroneckar deltas result in one Kroneckar delta with the indices KL. Now look at the fourth term. It is minus. We find that I repeats which can be contracted, and we can write Kroneckar delta JL, and delta KM is there. And now the fifth term, we see that I is there repeating, so we contract it to write Kroneckar delta JM, and Kroneckar delta KL is there, minus Kroneckar delta JL is there, and I can be contracted, and we get Kroneckar delta KM. A careful look at these terms show that these terms are same. So 3 minus 1 is just 1. Therefore, we have the first term, and then we find that the remaining terms are all having the same structure. So minus 3 plus 1 is minus 1. So it is minus Kroneckar delta JM KL. So we have proved this result. Let us have a relook at the left hand side. This is the first Levisivita symbol. Let us interchange IJ, so it becomes minus JIK, and we now interchange I and K, and therefore another minus sign will emerge which will make it plus. So this is what we get. So I has shifted to the other side, and similarly in this case also we can shift I to the other side and write LMI. So the point is that this is equal to and this is again equal to so it is JL KM and then JM KL. Using these properties of Levisivita symbol, we can derive, we can simplify, we can rewrite formulas with compactness. In other words, we can give a very short form to the formulae or laws using Levisivita symbol. This we discuss in the next video on application of Levisivita symbol.